Alrighty. Hi there. I am Chris from Airwindows, and I'm going to see whether I can't do another one of these Q&A sessions. Got an assortment of visual references and things. I got my chat up. I got a cup of coffee and the remains of a bottle of water, and we're ready to roll. And upon starting, I learned something interesting and kind of dismaying, which sort of figures. My Linux VSTs the last couple of times apparently have not worked for stable Debian releases. Doesn't that just figure? It's like anything changes and everything breaks. And this is why I don't like computers and why I like doing things other than computers as much as possible. Specifically, what happened there, hey Bo, is I moved the compiling of plugins over to a laptop. It is the same laptop that I was running Minecraft stuff on, and I installed a current version of whatever the audio and video processing version of Ubuntu is. I forget what it's called. Yeah, I Dream of Wire is just excellent. And in doing that, I ran the command line update everything and then proceeded to compile plugins, and after a little trouble where it didn't actually want to compile them for me and I had to install build tools and things because the stock install didn't include build tools, I included the build tools. And judging from one report that I've got, because almost nobody uses this stuff, I just make it because it's right to do so. The versions of Linux VST that I've been building aren't working on Debian stable at the moment. And I'm assuming that is because I installed this studio style version of Debian. Come to think of it, let me check something. Yeah, I'm fine. I was checking focus. I wanted to see whether I was in focus or not. So I had to install a new version of Debian, and rather Ubuntu. And it was an unusual version of Ubuntu. It didn't come with build tools, and doing like apt-get or whatever to install the build tools installed versions of the build tools that apparently were linking to libraries or something that are not actually compatible with things. So I did all the stuff that I was told to do. I was told to do it right, and it gave rise to being able to compile stuff again, and I was in fact able to compile stuff. In fact, it was compiling stuff so well that it wasn't compiling stuff that had been previously compiled, which is what the older virtual machine version did. And now apparently it doesn't work, so I got to roll back. I'm going to have to go back to the virtual machine version, which exists in a little time capsule, and I didn't get rid of it, thankfully. That's also pretty kludgy, but I'm going to have to redo some of these Linux VSTs that I've made recently. So if anybody knows at what point I proudly announced that I was running on the laptop, it might have been the time when, or shortly before, when I was plugging it into the A10 Mini. Like I showed you the desktop of that laptop. Unfortunately, I can't use it. I can't use this Linux laptop, even though it's much more effective and faster, because what I compile on it isn't compatible with Debian. So I need to roll back to the first thing I came up with, even if it's cumbersome, much like I'm doing my macOS builds on an antique laptop, which is, it'll be a virtual Linux box inside the antique laptop that I'm building on. And that's what I'm going to have to do. That is what I'm going to have to do, because I can't be having with the, much like Granny Weatherwax in the Terry Pratchett books, I can't be having with this not working on stuff. That's not what I'm about. Being like, oh, you better recompile and reinstall the newest this and that. That's not what I'm about. I'm not down with that. I'm not happy about this. So, if anybody who uses Linux can tell me at what point did my stuff stop working on Debian Stable, I would appreciate that. Because as near as I can tell before then, stuff did work. And that simply means, and I might be able to do it just by looking at the respective build things, but the build environments, like which things were included and which things were not. But at the same time, it might also be some of these reimagined dithers where they have the switch between 16 and 24-bit. So I can't just go by presence or absence of the new plugin like Bright Ambience. Some Linux users can't use my new Bright Ambience because it was compiled on a real Linux laptop with the build environment that was done the way you're supposed to do it, but became incompatible with older versions of Debian. So that's where we stand. That's where we stand right now. I'm not happy about this, but I will do whatever it takes to make it right. I don't care how troublesome it is. It kind of just confirms my suspicions about these computer things in general. And I will go and make it right. Whatever it takes, I will go and make it right. In among my other, like, here is a list of notes of possible plugins that I could make. Got my work cut out for me. So while I'm chatting with apparently 5 people, which is fine. Hi, Bo. Hi, Darwin Dees. Darwin Dees has a question. That question is, which non-dithers have safety clippers built in? Not many. Not many things have safety clippers built in. Normally I run in a more modular kind of basis, so you should run a dedicated safety clipper. Probably clip only is my advice. It's the one that I prefer at the moment. There are plugins that have a built-in limitation, but that doesn't necessarily constitute it working as a safety clipper. Like some of that stuff will clip and saturate. So yeah, and also looking through the source code can sometimes tell you things about that, but that's a big job, so I'm not going to demand anybody do it. Bo, tell us more, huh? I'll start reading them off. Reverb notes from Casey Abricasti. This is the stuff I was talking about last time, that I was intending to do an interesting combination between bright ambience for early reflections and later reverbs, and that's where I got the idea of these things shouldn't just feed into each other just because you can. This was capacitor 2. I've done this one. I guess I'm saving it just because it's a note. This is about the makeup of Helios consoles, the old like Rolling Stones Let It Bleed console, and ways in which they did boosts and cuts, what frequencies they used. They were largely based on inductor designs. I am actually hot to buy a cajillion tiny toroidal inductors. I know a place that I can get them. I've gotten a couple to test out, and I'm pondering the idea of going like, how much for all of these? many thousands of little bitty inductors because I tried them out. Currently, what I'm doing for my bass in the music jams that I do is I'm running a regular oscillator, and it can do sines and squares and sawtooths and stuff. And I'm running that into a simple inductor-capacitor-inductor combination, and running that through to the mixing board. And basically it's just a giant treble roll-off, but it did a pretty good job of doing it. Hey, Andy. Somebody's asking for Righteous 3. Somebody was asking for a Fletcher Munson cut boost. I resist this because I think it's a terrible idea, but it is possible. So I can talk about the inductors and capacitors in a minute. You personally asked me to do this, so I'm going to do it. Somebody was asking me for a particular kind of test tone sweep, and I could also do a particular kind of test tone. And the thing about me doing a test tone is I can do it dithered to the floating point bus. So I could do a better test tone than most people. And it's not complicated. It would be fairly trivial. Somebody was asking me for a bass fart plugin. What that means is a plugin where if they had the wrong kind of bass content, it would do a sort of grindy noise coming through into the audio, much as if they were running into a bad set of speakers because they were doing mix tests on the bad set of speakers. There's also notes here about a capacitor 2 style Holt and a big near space question mark, which won't necessarily I can probably do better things than just reissue near space. I think it exists in, I'm not sure if it exists in one of the reissues. And also there's a note about how diode bridge compressors, the peak can completely silence output. So I'm doing some experimentation with that. I'm looking into some of that. Andy, the reason we have so many types of dither is because I started out making those and I always experiment with new ones. That's the only reason. You can always just use a TPDF. You can always just use not just another dither. You never have to worry about that kind of stuff. And it is all supposed to do the same thing. And anybody who really fusses about picking out just the right dither for a particular song or something is being foolish. You need to figure out one that seems like it's okay. If you can't tell, then TPDF will work. Or Paul dither, which I just did yesterday. Paul dither would work. Paul dither is a TPDF. And you shouldn't have to worry about that. It's just one of the areas where I've come up with repeatedly new things. Like I beat TPDF with the spatialized dither, and then I did naturalize, which turned into not just another dither, and not just another dither was the best to a point. And I refined not just another dither a couple of times because I found bugs and fixed them and proved it. And then I did dark, and dark is actually better than not just another dither for pretty much all of the circumstances I can think of. So that might go into monitoring, but the thing about it is you don't have to worry about the variations. It's like the dithering to floating point stuff that I do. That's for me to be worried about and you to just be able to use. And it contributes to the sound of your mix and your system, but it's like the kind of capacitor in your board. You shouldn't be thinking about that stuff, especially not when actually mixing. So here's a gentler point plugin. I would be calling it transients. I'd have to check to make sure that it works in 96K. And the idea is I already have point. Point exists, it's out there, but people find it cumbersome to use, and so I need to do a simpler version that kind of automatically gives you the right sounds and is easier to set up, which shouldn't be that difficult. It'd be more like a preset kind of point. And yeah, Darwindies, you have a point. I would never no pun intended. I think Dark and NJAD do sound different, very different. I would contest because it's all about the level of least significant bit, but the way they behave is very different. And yeah, people do love worrying about which components are in their boards. So this is one of the reasons why I put this stuff out. and then I don't get rid of older versions or deprecate stuff very often. I'll do numbered series of things, but I do not, like, people love worrying about which components are in their boards. I do. My guitar rig is a Valve Junior amp. It's a $100 tube amp that has close to $50 worth of extraneous parts in it. Like, the tubes have been replaced. The capacitors inside it were replaced with very different capacitors that are insanely expensive, and it's still a tiny, tiny little Valve amp. So, go figure. Bass control and bass kit 2 need revision. So I have bass kit. It doesn't have biquads yet. It doesn't perfectly remove subsonic and DC frequencies yet. So I have some notes on what I could be doing with that. What I could be doing with a new subsonic boost, mid-side styly thing. Edge would be the energy plugin, but using parallel bands so that you can boost the bands that emphasize a particular frequency range, and that's going to be tricky. It's going to require some kind of calculation for what's going to emphasize particular frequency ranges most. That, or I'll just do a lookup table or something. But the idea is you should be able to use energy and slide the frequency area up and down, even though it is a sample rate related calculation that can only deliver narrow boosts at particular bands with some weird artifacts along with them. So the idea is to pretend as if it is sweepable even though it is not. And it would work best at a high sample rate, which is good, and it might require many more bands than energy has. But yeah, I'm not sure. I'd been wanting to do a square wave tremolo, and by that I mean do a square wave tremolo that does what my DVCAs do, and they are zero crossing gates. Now, I'm not sure I can do a gate in plugin form so easily, but I should be able to do at least a tremolo which does whatever you would do, and you can do a square wave tremolo without the clicking that you get from switching into a high voltage thing and going instantly to that point. Basically, the tremolo needs to turn on and off only when the signal goes through a zero crossing. And that would make it a interesting kind of effect that's different enough that it would be worth doing. Here's one that I was going to do called Mauve, which is a sort of Dead Mouse Kick inspired plugin. And V because that's a Roman numeral for 5. And the whole idea is that it should be possible to massage and manipulate a kick so that you'd have a sort of multi-band effect, but the lows hit first. And they're kind of all the waveforms are kind of centered around where they peak out most. So the lows would swing up first, and then the highs would peak out when the lows were hitting the most. And it would make a very striking, you'd have a kick drum that would have a lot of top on it, but wouldn't just be like clicking in your brain and being really abrasive and stuff. It would have some beef behind it. And that should be adjustable, and I haven't done it yet. And there's also a note underneath there saying that a double Butterworth or a triple Butterworth would make an isolator. Now, the trouble with isolators in biquad filters is you can't sweep biquad filters very well. So that's a problem. But you can sweep the Butterworth a little bit better than, say, if you had a really weird Q factor in the biquad where it starts to go crazy. So it is possible that I'll be able to do a sweepable isolator using biquad filters. Although honestly, it would be a better idea if I learned how to do state variable and I haven't learned that one yet. I've got biquads working, but I don't have state variable working. Here's one. There is a ultra-high sample rate bug in peaks only in monitoring, and I have some updates to do on that. I'm not exactly sure what it is. I'm not really using it. Isn't there I didn't actually say console 6, and console 6 doesn't use capacitor. Console 6 is just distortion and anti-distortion technologies. Doesn't include a filter. Focus, but with compression. That was an interesting idea, and compression does generate artifacts in terms of if it rapidly changes the amplitude of something. That can produce harmonics, and if the harmonics are beyond the Nyquist frequency, then you get aliasing. And it would be possible to do a focus, and I never said console. I was saying a different word. There's also the possibility of looking into curve and recurve for a focus-like behavior, because if you remember, curve and recurve are kinds of compressors. Curve is a very chilled out compressor, and recurve is that but with more gain and boost. And if I combined those with focus, it might wind up with a sort of attention directing kind of boosting. It seems like there might be a possibility for doing this. So I'm going to set that aside as possibly worth attention. Doing the recurve focus thing. I'm not likely to do a update on bus colors. I no longer like bus colors. I don't want to do things of that kind. ResiQ existed, but it seems like there might be a way of doing more of a scalable CPU hit. ResiQ was interesting because ResiQ is essentially a virtual, and there are a number of interesting things I could do with it. I could start including the sample, the prime number sample spacing that I can use to do something like that, because if I'm calculating out taps to make a impulse response, and that's what ResiQ is it generates a impulse response that does a really high Q resonant boost. And the thing about that is other stuff that I've got, like iron oxide and bright ambience, do sort of manual impulse responses in the way that ResiQ does them, but they space stuff out so that it is prime number spacing. What that means is if I generated a impulse for doing a tone control, like ResiQ's really tight filters. ResiQ's really tight filters are done in an unusual way. They are done modeled after what I saw happening on an impulse response generated by hardware. And it looked to me as if rather than just doing a kind of wiggly shape, I'll do that on this graph. You get something like this. And rather than just looking like it was that kind of wiggly shape, I thought that what I was seeing was sort of a faster attack into the impulse response that you got. Because if you use this as an impulse response, what you get is like a honk, a really tight, high Q, highly resonant, wah pedally kind of resonant honk. But doing it just a perfectly generated sine wave is accurate, but it wasn't what I was seeing on the analog hardware. So what you get is a different kind of resonant effect. Now here's the thing, and this became awkward because I had ways of updating the impulse response where I was trying to not update every single sample of the impulse response every time anything changed, because I thought that that would be really would kill people's CPUs, and the CPU would fall over and then your mix would die. But when you change only some of the impulses at once, you get really weird, crazy, freaky artifacts, and that's what ResiQ is like. It does really weird, crazy, freaky artifacts. And that, while fun, is not necessarily that great. And the way this relates to the bright ambience and the spaced out prime number stuff is that if you're doing spacing of a impulse response using these prime number spacings, say they were random levels, you would get essentially bright ambience. You'd get this really bright, and there would be a noisy effect to it. If, however, you were using a waveform like that, for instance, you would get something that's more like the behavior of iron oxide, because iron oxide is doing... Oh, hi, Mr. Photo. What the fuck's wrong with me? Fuck if I know. Iron oxide is using also kind of a spaced out, kind of like me. Iron oxide is using prime number spacing as well in its impulse response. It's just doing a different behavior. It's doing like an averaging behavior, but it's doing the spacing, and that's part of what gives it the sound that it has. So if we take this ResiQ, and instead of doing every single sample, we do only the samples in this prime number spacing, it's going to mess with the high frequency behavior a lot harder. You're not going to get clean output at high frequencies, but it's going to latch on to bass much better. So that could be the secret to getting something like this that doesn't just completely destroy the computer every time you try, but has enough of a window to latch on to deep bass. And that's probably worth looking into as well. That's why I put it aside. Here's one. Seriously, take it all the way. I did Seriously for Chad of Beauty Pill, and I was not able to do it properly, but I've been using an SRS processor on my reverbs for some time, and I'm getting more used to how it sounds, and probably what it'll end up doing is being a Seriously 2. And I'll put out a free plugin. You don't even know what I am, do you, Msipoto? Go to airwindows.com and download newupdates.zip. And if you're an electronic musician, I just gave you literally hundreds of VSTs and audio units. You're welcome. That's what I do. I'm talking about more stuff along those lines because this is the list of further projects that I have going. I've come up with a new thing every week. I give it to you. It is free. I'm Patreon supported, and I'm not hurting for needing to get money out of people, so go ahead and take my plugins and things. That's what I make them for. Here, sample delay. Sample delay would be VST normal audio units. I can define a latency using the forms that I'm familiar with, so I could do the reverse delay sample delay. And the way that that works is kind of like this, that you have the sound being made, and then you have the echo. So you can define a sample delay that is this long, but if you are running on audio units, you can tell it that the whole thing has a latency of like 50 samples or something. So what happens? Oh, if you don't have skills with music, don't worry about it. Stick around. Maybe you'll pick them up. We can all relate with that. Everybody starts somewhere. In any case, getting free software to make music with probably will help. It's not like you have to spend money to learn the skills. Get the plugins and then try something like, I don't know, Audacity, download a free program and start playing with it. This is a fine place for you. Don't worry about it. So the latency, the audio unit, basically the problem with that, and the reason why I don't normally do it, is the audio unit sample delay has a negative delay capacity. You can put it in and manipulate the control so that you anti-delayed something and it happened like 10 samples earlier than it existed. But it's a trick. What's really happening when you put my AU sample delay into a AU system like Logic or whatever that has delay compensation is that sample delay immediately tells you to delay the entire mix and everything in it by like 50 samples. So it's lying when it says, oh, it's -10. Instead, everything is delayed by 50, but that's only delayed by 40, and that's how they do it. So that's the sample delay thing. And the reason it hasn't come out yet is because I don't know how to do that in VST. I don't think delay compensation is very well thought out in VST. But that's how that's done. That's why I don't normally do it. Typically, my stuff with my plugins generally run 0 latency. And that actually is positive because I feel like a lot of things, when people are tracking and making mixes and stuff, it's really a good idea to record stuff directly into a mix. I'm not the only person to think that, but I am strongly in favor of getting your mix set up and recording stuff into the mix where it is supposed to exist in the mix and kind of building it as you go like that. I think it's a sort of modern DAW-like way of doing it, but in order to do that properly, if you're going to be monitoring what you're playing in there, you're going to need to have no latency or as little latency as you can, otherwise you're just going to be pretty hosed. You can't really play if you're running a bunch of plugins and the plugins are all running like, 20 milliseconds latency. You can't play along with that. It winds up becoming completely unmusical and distracting. Here's something else. This is the amps. I think it's Andy who was looking for my amps. None of these were any good. These were all from like 2007. I should be able to do better now. But I do have that as my list of stuff to do. Here's an idea that I am not even sure what it is. 80 clip. Combine adjacent samples, clip slew only, clip anti-slew only. I'm not really quite sure what that meant. I'll have to figure it out. Some kind of interesting thing. Amps are not here, but eventually they will be. Righteous 5. Somebody was wanting that. Duo biquad. That would be kind of like the thing I was talking about with the isolator filter that's multiple Butterworth filters. Butterworth is only a resonance setting. It's a particular Q factor. It's a particular roll-off factor. Less roll-off and the slope becomes much less. More roll-off and it starts getting more resonant. So something like duo biquad would be a handy way of just cobbling together stuff in mix. Like if you were testing stuff out and going, I want to do a amp thing. What should I go about testing this out? Like, let me hear what this particular variation of biquad sounds like on this guitar. And if you do that, I've got existing biquads and things, so you can dial in some of this stuff, but it's not necessarily as convenient to be like, I'd like to know what 2 biquads in series would sound like so that I can get the steeper slope but without the resonant peak. or maybe a certain amount of resonant peak, because the thing is, with the steeper slope, your resonant peak is also going to be narrower, and that has its own uses. So if you were going to do some kind of setting, some kind of behavior where you wanted a sharp little resonant peak on things, but only a certain amount, you could dial it in so it wasn't exactly Butterworth, but maybe a little tighter than that, and then set your frequency level and be like, that's perfect, and then build that into your new plugin. Be like, I have experimented with the duo biquad. It let me set two different resonant filter frequencies at the same time, and I'll just use that. So yeah, this is the note that I made on the base sorting thing, which I believe Bo has been desperate for years. And it's just a bunch of sort of notes on how something like that could possibly work, although it is still not capable of keeping track of multiple buffers. Here's one. Twist, DC offset, scale, sine, anti-offset, anti-sine. This is an idea for a console variation. I can do a variation of console that uses all of the technologies of console, does the same expanded type thing, but also has a fundamentally even harmonic oriented thing. Where, like, I can make it clip differently. I can make the space added by console be more effective glue. And that should be interesting, and that requires some fooling around with. I'm going to have to experiment with that. It will also be much more fussy about setting it up exactly right. So when people are coming around being like, how can I do console exactly correctly, and what does this require? That'd be one of those things where, for a change, it'd be like, well, actually, this time you do have to do it exactly right. No, you can't touch any of the faders, because rather than just adjusting the sound quality, you're actually going to be throwing DC offset this time if you do it. So there is this sort of expert mode console version that can come out. And then lastly, this one is my golden dither idea. The idea is to do a sort of Gaussian style dither, but I have a concept which might possibly work and which could give rise to what would not actually be a TPDF dither. It would be something else. I'm not sure to what extent it would decorrelate all of the because the thing with dither, how dither works, if you do 1 bit worth of random noise, then what you will get is you decorrelate the notes out of the quantization distortion, but the loudness of the distortion fluctuates with the frequency, so you still have that audio coming through. TPDF dither is 2 bits, both of them random and different randoms, and one of them decorrelates the notes happening in the quantization distortion, and then one of them decorrelates the loudness of the fluctuation of the quantization distortion, making it so that there is nothing but just plain noise. And what you get is that noise. However, I've also felt that it is not very realistic sounding noise. It's very sort of digital, bright, electric kind of noise. And I've wondered whether it's possible to do a kind of noise that would do this, but would also sound more like acoustic noise, background noise, environment noise. And I wonder whether something more Gaussian would work. And so basically I'm doing an experiment with golden ratio calculations, and also figuring out what degree of offset I could make so that rather than the entire noise floor existing within exactly 2 bits of least significant bit, you cover more than 2 bits, but the distribution shouldn't necessarily be 1 bit and then the adjacent ones at equal levels. Maybe it should be golden ratio of 1 bit and then 0.618 of the time you're also touching on the other one, and then 3.81? 0.381 of the time you're going above the area. And I do not know what the correct answer is to these things. In a way, it's like there is no correct answer because I'm just exploring these ideas and I want to know whether they sound good. And it's impossible to measure whether something sounds good. You try to recognize when something sounds good, which is not always an easy task and it can lead you astray. But the idea is to build a Gaussian dither out of this exact form of basically I'm just going to try to see whether I can make that work. I can't get much more into how it's done. It's hard and confusing, and there's a lot of stuff going on there, and I'm just going to do my level best with it is all. If I do, then I'll end up with a new TPDF style dither that won't be super quiet, like not just another dither or Paul dither, or tone shaping like dark. So basically, and I'll probably be calling that one golden dither because it is based on the golden ratio. And that's my list. I do have other visual aids here, but I don't have another copy of the list. This stack, not counting these, this is my workload. Not counting the stuff that is coming out, I do have some stuff coming out that is done and that uses the work that I've been doing in Capacitor too. So it all kind of ties together in the long run. But yeah. So Ian has a question. You should ask your question. Asking a question about console if possible. By all means ask. And Andy, yeah, I know. Your problem is that I'm not satisfied with just putting out the old AMP simulations because I hated them so much. I did not like my old AMP simulations. I don't use digital amps of any kind. I only use analog and real guitars and stuff like that. And so my standards are pretty high. And I've been really unsatisfied with everything that I've done in that direction. And I've been really unsatisfied with impulse responses for cabinet simulations. So since I've hated those things so much, I've not done a lot of work in that direction. And I'm not willing to just put out the experiments that I did in the belief that that's going to be okay, because I think it's not. But the work that I did on Bright Ambience and the most recent version of Bright Ambience has been useful as far as envisioning new ways of doing that stuff. Like between things like Focus, which is a band-limited distortion, and things like Bright Ambience, I'm really starting to feel like I will be able to come up with something that won't be an exact replication of some amp, but will be something where you can plug a DI guitar in and get a sound that is musically useful. That, I think, might be possible. And it could end up being very different from any known amp, but it probably would end up being voiced in some ways that are fairly similar. And I'm probably not going to get into a super high gain thing either. I don't know, maybe I will, I'll have to see. But in order to touch upon this, I basically had to reinvent how you even do such a thing. And I'll be using all of that stuff. You know, anything like I've already put out Guitar Conditioner. Guitar Conditioner doesn't currently use what I learned in Capacitor 2. So that could maybe do with an update as well. And anything that I do as far as doing a new amp thing would need to do that stuff, would need to be the kind of thing where it's like, okay, this is Chris's plug-in guitar amplifier or plug-in guitar voice. Maybe I wouldn't even call it an amp. And the whole idea is, yes, you can plug in DI, and if you get a good enough sound on your guitar or whatever else it is that you're doing, we can make something that's musically useful out of that without making like it exactly duplicates some form of real-world amplifier, because I don't think that's possible, and I'm not sure that's necessarily desirable. It's always more interesting to do something new. So Ian's got his question up. When grouping tracks, a drum group consisting of separate drum tracks. If you have console bus on the master, I would suggest having an instance of console channel on each individual drum track, so long as each individual drum track goes unity gain to the final output. It's best to have all the little bits summed using the console technology rather than like sum them to a group and then start using console on it. That said, the whole purpose of using Airwindows console is to give some of that space around instruments and things. And that doesn't mean you necessarily want space and atmosphere around every individual drum sound. It's possible that that would start sounding like too distinct, too discrete. So it's always possible to do other stuff. Maybe you want to do the opposite and like smush together all the drums as much as possible and then mix those with everything else with space around them. But the whole idea of console is, rather than have stuff be really 2D, and again, this is like, if you wanted stuff to be 2D, you'd be using something like DRes. You'd be using something like a bit crusher. And that's very good at taking out space. So the thing about it is, if you like what the console system does to the way things combine, and a drum kit is a good way of experiencing this, you get the most out of that by having the console bus plugin sitting on the final output, and then everything gets summed at unity gain through individual instances of the console channel plugin everywhere they belong. I've done experiments where I was doing sampler instruments, and I encoded console channel into the sampler instrument, and then ran that directly onto the bus and into console bus on the final output. So inside the sampler instrument, and anything involving it was part of the console system. You could have like a piano and hold the sustain pedal down, and all of the individual notes were being summed in console just because that's how that stuff works. So yeah, there's your answer. See whether it sounds better with console channel on each individual drum track and with space around every individual mic. It might or might not. You might not find that desirable. You might want to do something very different. For instance, if you were bit crushing the entire submix, at which point there would be no point in running a console channel on anything, up to the point where you bring that into the overall mix. And when stuff reaches the overall mix, that's when you're using a console channel to get into the summing bus, because you're replacing the entire summing bus, basically. Anders Hellquist was asking something. Could somebody repeat which bus color modes correspond to which non-official emulations? Well, I can tell you some of that, certainly. I know Lush was based on a actual Neve preamp impulse. So Lush corresponds to Neve. I think Dark is something... Oh, God, I don't even remember. Rock, of course, is an SSL preamp impulse. These are not actually the recording devices, that's the thing. People are behaving as if this is the console. It is not. It is a impulse at a bunch of different levels made by a guy who badly wanted people to emulate a set of preamps and things for modeling it. Basically, they wanted what Nebula now does. And so it's like Holo would have been a Precision 8? Or it's been a long time, and I certainly never dedicated a lot of effort to being like, this is my model of this particular preamp, so you don't have to buy the preamp anymore. That was never what I was about. Now I remember. Okay, Rock came from Cider. And Cider was based on an MCI, but it wasn't really an MCI. It was just similar. It was the same derivation, sort of the same bloodline of consoles. And so Rock, in the Bus Colors universe, corresponds to like an MCI style console, except for not really being one. There was one that came off of Focusrite, I forget exactly what, and some of those other ones, like Vibe, I don't even know what that was. There are not actually corresponding things to this stuff. There really are not, because in addition to that, the way that they're synthesized out of a low level and then a high level and then somewhat exaggerated means that they become their own things. Like, it's no longer, even if it started with, like Lush started with the Neve impulse, or Tube started with a Manley Voxbox impulse. And even if it started with this, it became, this modifying factor is this impulse minus this other impulse. So we start with the lower level one, and then you change it to seamlessly transition between the lower level one and the higher level one based on whatever amplitude it is that you've got at any given moment, except for there was no, like, the middle stages no longer correspond to anything in the world. And then if you crank up personality in the old character plugins, or whatever I did with them, you wind up with new impulses being generated for high level stuff that no longer correspond to any real world thing at all. So to ask what the settings are is misleading, and something that up with which I will not put. There is no longer like a manual Voxbox. There is no longer a Neve preamplifier in any of those. They're just sort of the building blocks. It's how this stuff started, was impulse responses taken at different signal levels. And then it just got changed around so much that it ended up being a completely different beast. And again, I'm more interested in doing stuff along different lines. I've never been that much of a fan of trying to do stuff using impulse responses, because it's just putting a coat of paint on what is already there. And I'd rather do algorithms that shape what you get, rather than believing that you can make stuff behave a certain way by putting the right coat of paint on it. That's basically where that stands. And that takes us to pretty close to 12 noon, so we're about halfway done. Maybe a little over halfway done or so. One of the things I did bring was I got some of these, and I thought I'd talk about that a little bit, although people aren't necessarily interested, but this is the kind of thing that I think you should start being interested in. This is a Teensy 3.2, but there's also another thing in here as well. And I can probably safely take them out of the bag. Although I don't yet have my... Oh, yeah, Bo, you did mention inductors versus capacitors. There's no such thing as inductors versus capacitors. That's not how that works. But I can make notes for you and show you how some of this stuff works. So this is 18C3.2. This is, I don't know, about $12 or so. And it is the guts of the Music Thing modular chord organ and many other possible things that you can do with this if you're building hardware synths. The way you do it is you plug it into a computer. So you have to have some form of computer, program it using an Arduino programmer, and you push this little button, boop, and it loads its new program in. So it's a tiny little computer, but it is a tiny little computer that can run a waveform generator. You can tell it to do sample playback. Like the same deal is also this is also the guts of the radio music. And essentially the radio music is running off of exactly the same thing. So it's using the same 12-bit analog output. But using the signal generator, you get to set the sample rate to like 340 kilohertz, meaning that for normal waveforms, like your squares and your sawtooths and stuff, you get a steppiness from the 12-bitness of it all, but you also get next to no aliasing because you can run it at this extremely elevated sample rate. So $12 signal generator, y'all. $12 oscillator for a synthesizer. And I think this is a really great, plus there's also all these other bits. So it's like it could also be your sequencer. You just program it to do that, and all these little wires coming off of it. You got a little chart showing you what everything does. And you can be like, okay, this one triggers this set of CMOS chips, and we're going to do a clock. And so this gives me my 120 beats per minute, or however many beats per minute I want. Spell it out, make it do the correct thing, and trigger a bunch of other stuff off of these other pins. And you just run a wire in there and start soldering things together. And then further experiments. This is like a $5 or $6 thing. Same deal, kinda. You plug it into your computer using the tiny little USB thing. You push the button, and that tells it to load a new program. It has fewer pins. I don't know if it has the analog output, but it's like a $4 or $5 chip. And it too is a tiny little computer. So maybe if you were going to do something that was just like a clock, and it needs to go tick, 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 you get one of these rather than having to do the full TNC 3.2. And you power it and you run it. And in programming it, maybe you set it up in such a way that you can plug stuff into it. You can build it into your weird homebrew synthesizer creation and then hook up cables to it. Doesn't want to fall in. And in doing that, you'd be able to sort of revise and reorganize whatever synthesizer you were building. Because there are a number of things about this. I think I was talking about how I'd watched the I Dream of Wires documentary. I was talking about how I'd watched I Dream of Wires. I got a extended 4-hour version, and it was very cool, and I enjoyed the hell out of it. And here's what I'm envisioning as far as that. And I'll get into I'll get into inductors versus capacitors soon, Bo, because this leads up to it. You've got all of these synthesizer makers doing stuff like that, my modular stuff. And generally, they have to be able to make faceplates. They have to be able to etch circuit boards or order quantities of circuit boards and build surface mount technology and stuff like that. And it's possible to build analog synthesizers and or digital things in this way. but I wouldn't call it approachable. I feel like the learning curve for that stuff is kind of stupid high, and it's intimidating and overwhelming, and it would also cost you a crap load of money to get things like drill presses and stuff in order to do it right. Even if you were building your own faceplates, you would be needing to drill holes in things in them and or label them. Maybe you're getting some kind of computer-aided engraver so that you can make logos and things on the faceplate. Or if you're doing stuff using circuit boards, though that looks a little more janky, you can design them, but you need to be able to use the circuit board design software, which can be expensive if you're getting the real deal stuff. And then you have to be able to use the crap, and it's really quite overwhelming. Meaning that I haven't been able to learn how to do it yet. Maybe it's not. Maybe it's me. Maybe it's just me. But thousands or tens of thousands of dollars to really get up to speed to this in a level where it looks like you belong among the other designers building stuff like dope for Moleco. Music Thing Modular is a very sophisticated setup, even though it's, kits that you build yourself. Those are nice faceplates and everything. And all of that stuff ends up costing the damn earth. It's unaccessible. You wind up with only people who are very privileged being able to do that kind of stuff, and I don't like that part. Whereas with things like these, you can get one of these for $5. You can get this stuff much more easily. It's just a question of what are you going to do with it? What kind of form can you take for building something that's interesting? And here's the interesting part to me, is that there are also, and I can't remember the names of the things off the top of my head, because like I told you, I've got this list of plugins to make, and I'm clearing out space in my basement for being able to get quantities of hardware stuff to redistribute, and it's a lot on my mind at the moment. But there are vendors who are essentially building instruments, and they're able to charge boutique prices for some pretty wacky stuff. Like, I wonder if I still have over here. No, but over here, just a moment. I'll grab a couple of different things. So yeah, same place that I got this. I also got one of these. That's a Raspberry Pi. The crazy thing I've been doing the visual effects with, which is a Sleepy Circuits Hypno. I got one of those. I'm very thrilled with it. There's stuff that went into this. I would never be able to go through all the process of doing that, but it's a Raspberry Pi. It's a Raspberry Pi with some knobs and jacks and things. And it's been thought out and designed in such a way where it is usable for this very creative video hacking stuff where you can make your own video effects. And I feel like I am completely happy with having thrown money that guy's way to get my hands on one of those in working condition, because it has enlivened my music YouTubing thing enormously, and I still am coming up with interesting stuff to do with it. I'm layering it differently in OBS so that I can get a different effect out of it, and OBS is free. So now that I've got that, I can basically run with it. I could take 4 of them and run them into the ATEM Mini. That would be a really intense video jamming thing, is running that many things into an ATEM and then switching and modulating and green screening or luma keying them into each other. And again, real faceplates, real expense as far as getting all that kind of stuff together. But there are people who are taking stuff like Raspberry Pi guts, for instance, learn how to program that, build it into the SD card, build it into your synthesizer, and this provides the audio. Or this is something I built, should probably still work. This is an axolotl with a bunch of extra stuff wired into it. And I've got things labeled here. They don't really relate to anything anymore, but that's what I was doing at the time. And as you can see, I wired wires up to all these various pins, which is how you do this sort of thing, and split it apart and made it so that I can go into a Eurorack system, and came up with power so that I could power it off of a Eurorack system. Turns out I could just run the 12 volts into this area that only really wants 9, and the voltage regulator will still handle it. So you can do these, and there's folks that are doing stuff like that, or doing just raw CMOS circuit banging. And again, Raspberry Pi, maybe $40. The axolotl was along the lines of $70, but it has a lot more sophisticated, like it has much better converters. The axolotl will give you nice high quality analog outs, although they're not modular level, but it'll give you nice high quality analog outs. You can use it as a guitar effect. You can use it as a synthesizer that produces good digital to analog conversion. And then you can also build stuff out of CMOS chips and inductors and capacitors, getting on to Bo and what Bo was talking about. And there are people who are, as near as I can tell, making a damn good living off of building strange synthesizer devices. Like, I can't remember the name of the people in particular. Oh, by the way, when you're saying the feed is lagging a bit, do you mean that it's hiccuping or coughing, or it's just that it's very delayed? Because I'm not doing super low latency. I'm not seeing a lot in terms of dropped frames or anything. Zero dropped frames. So in theory, this is going to be fine. Maybe I'm not. Is the audio out of sync or something? Tell me whether everything is broken and wrong, and I should give up and never come back. No, I'm just kidding. Anyways, regarding, as you've now distracted me with the talk about the feed being broken, that's fine, whatever. Oh, hang on. Oh, no, wait. I just didn't press play, that's all. So here's the thing. I feel like getting parts into the hands of people who can solder them together and invent interesting synthesizers and things is a way of helping people do their thing and like interact and engage with the world using it. I cannot remember the name of like Ventolin and Barbary or something like that. There are people, have you ever heard of, no, I can't remember the name of the YouTuber. There's a German YouTuber who drinks a lot of whiskey, which never sits very well with me. But he likes Heinbach. Heinbach is the guy I'm thinking of. Heinbach, as well as drinking lots of whiskey, is very into building stuff out of test equipment. Now, test equipment can be surplus, but it still can end up being costly. But he's also interested in some of these weird synthesizer creations. Like Organelle is, I believe, one of the ones that he does. And some of that stuff is interesting in that it's all creativity and artistic nature, and much less of it is heavy manufacturing capacity and the need for really expensive gear to build your thing. Like some of that homebrew synthesizer stuff that Heimbach is into is made by basically small artisanal producers who are wiring together their chips with just chips and wires and stuff. And this is what I'd like to encourage. As you can see, I do that too. So in theory, what you can do is you can wire stuff together much like this. It doesn't have to be based on an axolotl, although it could be. It makes it easier to build stuff. And then say if you're doing a base and you want to build a base and it's got to be the most ultimate base in the world, but you're not really quite sure what you do, I'll tell you. You could build, say, start with a FM base off of this. It's an axolotl. You can $70 or so, or indeed $12 or so for the teensy, and program this to do it. I believe that's still going to be possible. I haven't done it yet. If I do it, I'll let you have the source code for it, much as I have for the chord organ thing. So I've already got ways of doing this. And then you're intending to make a base, so what you do is you do that, then output from the board that you've got. Through one of the inductors that I've been talking about, that I want to get large quantities of these inductors because I found an inductor that you can get that seems to be, it's not a very high inductance, but it's a big heavy wire in there, and it's toroidal, meaning that it's not going to pick up interference from external magnetic fields. Like a toroidal thing, a toroidal inductor won't pick up hum. It won't pick up buzz, or certainly not as much, maybe not at all, from fluorescent light fixtures and things. And I found a place to get a bunch of toroidal inductors for very cheap, so I'm thinking about maybe making a deal with the guys and saying, give me all of yours, the surplus place, you see. And what you do is you take the output of your synth, whatever it is, whether it's like CMOS chips or whether it's an axolotl or whether it's a teensy. If it's the teensy, you can tell it to play sine waves and square waves and sawtooth waves by programming. And that can be convenient because it'll do predictable notes. It'll be a little less crazy. It'll be a little more controllable. I believe you can also tell the teensies to accept MIDI signals, so that could be a thing as well. And then you run the output of that through one of these inductors. An inductor blocks high frequencies and lets through low frequencies. And then over here, it's going to a capacitor. A capacitor blocks low frequencies and lets through high frequencies. This is ground. The synthesizer part is also connected to ground. And then the output of that goes through another inductor, because why not? And there's your output. And you've just made what I'm currently using on the bases of my synthesizer rig when I do my music jams. I set it up so that the output of one of the chord organs is going through a VCA, voltage controlled amplifier. And it's one of the DVCAs, so it's only turning on at a zero crossing, so that's already smoothing out attacks, even though it's a very quick attack. And the output of it is literally going through one of these inductors. There's a capacitor to ground. It's not a huge capacitor, but it's actually fairly large. And then another inductor, and that's going into essentially, if I'm not, it's going into the same preamplifier that I'm using for this microphone right here. And that's how it gets into my mixing board. So inductors and capacitors, it's never inductor versus capacitor. They work together. I'll do another little sketch. We did this in order to get rid of all the high frequencies. The inductor gets in the way of high frequencies, and then the capacitor lets them through. So This is already blocking some highs. This is providing a conduit to ground for the high, so it's a tone control. Without the inductors, you've got nothing but a tone control like you'd have in a guitar. And then there's another inductor. So basically, this is just drastically steepening the amount of wiping out of the highs that this does. If you were to do the opposite, say you want a really intense high pass. You want all your low frequencies just to go away, no matter what they are. You do this. Output of your thing goes through a capacitor that blocks low frequencies. Then, in the middle between these two capacitors, there's an inductor. It goes to ground. That lets low frequencies just go straight to ground. It only resists high frequencies because the inductor is going to try to block higher vibrations from getting through. And they can go through the capacitors, so the higher vibrations go straight through. And then the lower frequencies it gets, first it starts getting blocked here and blocked here. And then it starts leaking through to ground because it's going through an inductor. And you wind up with a really, really, really steep filter slope. And that is what an inductor EQ is. Here's another funny one. Notch filter. All right. It would be a notch filter if it was to ground. Bandpass filter. You set the right values of inductor and capacitor up, and this is one of the most high quality sounds you can get. This is, I'm pretty sure, the same thing that is in the Moog fixed filter bank, like the old Moog fixed filter bank of the old modulars, and also in the Polymoog. When you have that sort of wah pedal type effect, and this is also what you'd find in wah pedals, if I'm not mistaken, but I'm not quite sure how you vary the frequency in the way that wahs do. But this is learnable. Like, I can look up some of these schematics, and better still, you just take some perf board and start wiring stuff up, see what you get. Things that are possible to run in battery voltages, you can play with. And that's what makes it interesting. I've done some really neat things in my day through just wiring up battery circuits and for audio purposes. And the lovely thing about it is that if you do it properly, like capacitors could cost 10 cents, 1 cent, really huge ones might be like 50 cents. The ICs can be 39 cents roughly. Getting the right kinds of op amps and things, also along the lines of maybe 30 cents, maybe you get a really fancy kind, and that's going to be a couple of bucks, but that's still only $2. You can get entire oscillators and filters and things in IC form if you know where to look. Like, get some of the Curtis stuff. There are people that are making ripoffs of the Curtis stuff that's even cheaper, but the Curtis stuff is still only about $14 per chip. You compare that to the price of an actual synthesizer, and that's a damn bargain. So you can have a real Curtis EQ chip, and basically you set that in your circuit and then run resistors and controls and things to it. And it should be possible to build some really cool things, and that could be to make your own music with, or if it turns out that, like some of these Eurorack designers, you find that your music is not all that exciting, but you sure love building the things, that might be a line of work. Because, again, getting back to some of the stuff that Heinbach has talked about, he's really fond of some of these builders. Now I want to find out. Give me a second here. I'm gonna look up so that I can shout out literally the name of the developers making the synthesizers that he likes. I'm going to do Heinbach synthesizer DIY, but I don't think that's actually going to get me it. So instead, maybe Barberry? No, I don't think so. Ibox synthesizer collection. I should be able to find the one that he likes off at that, because I want to shout out this particular one. It's not on his webpage, I know that. Bo, I'll get to your question in a moment. I'm busily trying to find out something. Hopefully he won't play stuff off of his YouTube channel, because I don't want that. But I bet I can find some reference to something having to do with what he's doing. He's got stuff like, earth-shaking bass drum. He's using OP1, which is much more expensive. Actually, I wouldn't say that that's much more expensive, but that's much more technological. And I'm looking for whatever the thing is that he's done that is not nearly as technological. Videos is not getting me it. Test equipment, music creation is not getting me it. Okay, this is now frustrating. I ain't gonna give up, but man. I want the name of that equip board. Okay. I'm trying to find the name of this developer badly. Bastel is cool. It's not what I'm thinking of, but Bastel is cool. Seat Lombard. There we go. I found it. What I need to do is be able to copy paste this, though. Wah. I'm super frustrated. Here. This should paste. I got this off of one of his videos. So if you ever heard of Seat Lombard, here's the thing. I want to put that technology in your hands in a slightly different form. Seat Lombard is somebody who is wiring these electronic parts together to make some really interesting, freaky, glitchy sounding stuff. Some of these guys doing this kind of thing, people are, oh my God, you are such geniuses, partly because they are not going by traditional forms of how you do electronic circuitry. Instead, they're getting a little funky, getting a little crazy with it, and making some really wild stuff. And the interesting thing about that is, if you are patching together raw parts using like raw wires and stuff like this, and then rather than using full circuit boards, like the Axolotl is a little tiny computer, that's basically what it is. It has many capacities. But if you do this rather than with these very integrated circuits, you're doing it with, or this is very integrated circuits, but you can see all the bits inside are incredibly tiny. You can also do it with more normally sized parts, or you can do things with very old school technologies like the wires that I'm using to run to these jacks. And these jacks are themselves kind of expensive because they're 1/8-inch jacks. They're Eurorack compatible jacks. And even though these are cheaper than some and larger than some, they're still going to run you maybe close to $1 each, and that adds up real fast. But they're capable of handling voltages and amperages that resemble what you'd find in the old synthesizers. But you can also take, so here is a header. This is what we normally stick things like this on. And you can get IC sockets that you can plug pins like this into, or you can get wire that is the same gauge as this and that you can plug into the IC socket. And the thing about plugging things into IC sockets is that all the connections that you make doing that And IC sockets are cheap compared to these other things. All the connections that you make doing that are capable of pulling as much amperage as it requires to feed a hungry CPU, which could be, like an amp or so. They're very good connections. They're just tiny. They're miniaturized. And if you build something off of your raw parts using all wires and connections that are beefy and powerful, you get more of your old school Moog modular kind of sound, because that stuff was built with big old wires and connections and switches and stuff. That's part of the reason why it sounds the way that it does. If you look at the surface of a circuit board, the way people make things these days, the wires in here are incredibly delicate and tiny. That's the reason why some of the connections going to like power supplies are heavier traces. They're trying to fit so much on there that the sound starts to suffer, because all of your connections are going through these delicate hair-like wires all the time. And if you build stuff using this old school technology, you can make instruments, you can make synthesizers and things that have a beefier sound. And that's part of what's going on with like the Seat Lombard stuff that Heinbach is so into. That somebody is building these synthesizers, building these correct creations, not at all in the form of modern super high tech, has to have a glossy surface. And some of that Seat Lombard stuff is built out of wood. And if you've got a whittling knife and some softwood, you could build stuff out of wood. You don't require a drill press to work with wood. You don't require a drill press to necessarily work with this stuff, this perf board stuff. A little pliers or something, a X-Acto knife to score along the holes, and you can snap it into whatever form you want. It's not that high tech to use. Like this part was rather difficult because I had to make all these holes be the right size and fit the right things. And that's about as hard as it gets as far as working with this stuff is concerned. So the idea of that hardware stuff, the gear building streams I talked about, is going to be both coming up with designs for circuits and things, like mocking up wiring together stuff and going, this sounds like this. This is where I would put an inductor. I want this to be darker, so I'm going to put a capacitor here. And I'm running into this op amp. I'm going to choose this op amp instead of this op amp because I want it to have a slightly darker, grungier sound, so I'm choosing this thing and so on. I can do that for hours on end. But the other part of it is that if you had a soldering iron, an X-Acto knife, a pliers, people should be able to start doing this without like getting a house and then mortgaging in it in order to get all of the expensive hardware that you need in order to build the faceplates and panels and all of that kind of stuff. And I think that's really important, because when I look out at the world of like my synths, and this is all stuff that I love, some of that is driven by very clever people with a lot of high tech on their hands. And they've got like amazing faceplates that are lovely, etched aluminum and just beautifully made. It's the Mercedes of synthesizers. And some of them are maybe a little less fancy, but they're still pretty high quality. The Music Thing Modular is like that. It's very high quality for the bits that it has. And then it's got these potentiometers and these knobs and things. And then some of it, like the Blue Lantern stuff that I love, it's made out of circuit boards. If you mastered being able to build that stuff, you'd basically send away for 100 circuit boards, and those become your faceplate, and those become the guts of whatever it is that you're making, and you'd have to design it all and make it all work. but to an extent that becomes more accessible, but you still have to buy knobs and things like that. And then you wind up with, hang on a second. I'm going to show you something. I made one of these. This is what I could do with building stuff on stream. I used the perf board that I used for this, and this is a CMOS chip, and there are some capacitors. I took little potentiometers that are just, they're called trim pots. These are cheaper than the regular kind. I didn't get knobs for them. They don't have knobs. Instead, I glued some perf board on so that I can turn this more easily without a tool, and that's probably, I can probably run with that as like, we'll just use these for the purpose now. Just glue some perf board onto it. If it breaks, desolder it and put a new one on. And the most expensive bits are the jacks and things, and the cables that you would connect them with. So what if you build an entire synthesizer out of this? The chip costs like 39 cents. Supposing you have a whole bunch of perf board. You got some wire. I'm looking to get in some more wire so that I have large quantities of wire, all of which is the right size to connect into IC sockets, because that becomes your patch cables. And you got some of your knobs. I got a hold of like trim pots in the thousands so that you can get them at a volume discount. And you wire together something like this, but with more bits to it. And then rather than having to drill holes, you take push pins and you put the module into pine wood, something like that, that'll hold it in place. And then you build a whole bunch of other things like that. Yeah, there are tiny little knobs available for a lot of trim pots. That would probably involve buying them. What I'm talking about is, suppose you only have like $5 worth of chips, and you've got some capacitors, and you've got some trim pots, and doing everything with jacks and Eurorack plugs would cost you another couple of $100 to really do it up properly, so you don't. Instead, you get the IC sockets, and you get, just a moment, you get this kind of wire, and instead of having these jacks, because this is for a Eurorack system, this worked in a Eurorack system. In fact, it's kind of funny the way this works. This is interesting. You notice how it doesn't have a power supply? The power supply is driven off of the gate input. Basically, the gate input is expected to be yay many volts, and it's also running through a trim pot to tone it down. And it's just enough voltage to make this start oscillating, at which point this adjusts the tuning of it. So this is a little sort of squeaker oscillator that is supposed to make noise behavior. I stole it off of a Reddit post. Somebody was posting like, here is my noise behavior. And there's a crude tuning thing in here. You have to set it exactly right in order for it to have a noise-like behavior, because it really doesn't want to. And then this sets the overall power for it, and there's no voltage required. All that's required is the gate output from whatever sequencer you're using has to be strong enough to be able to make this go on. So it will be a certain amount of voltage drop. That said, if you're doing that, you could use a transistor to power it more easily, or you could run the output of your gate through an op amp, and then you'd be able to power it using the op amp. There's any number of things to do that way. And you take the output off of like this wire, and then rather than having to get a Eurorack cable that's like 1.5 feet or 3 foot or whatever, just unroll this much wire, strip the end of it, plug it into your new jack, which is a IC socket or a piece of an IC socket, and you're off and running. And if it's a good enough connection, you just leave it plugged in there. But if you need to repatch it, then you just carefully unpatch it and stick it in somewhere else. I really feel like it should be possible to get into modular synthesizer and DIY synthesizer stuff for absolutely dirt cheap if you're willing to make some sacrifices and meddle with things the right way. It involves doing stuff like this. It involves building things out of the raw parts, which are not the expensive part. Building stuff out of things like trim pots, because you can get those for cheaper than the full-on pots. Using things like gluing on bits of this rather than getting actual knobs, because if you have 100 controls, say you're making a 100 oscillator drone synthesizer, right? That sounds fun. Would you like to have a 100 oscillator drone synthesizer? Would you like it so much that you need to spend hundreds of dollars just to have the knobs and pots in order to do it? And suppose you want to patch it in, then every one of your oscillators, supposing you want to patch it separately, requires its own jack. So one of these is like $1, so that's one from what you're patching and one from what you're patching to, so that's two of them, so that's already $2. And then the cable is going to be along the lines of, I don't know, $2 or $3, and so that's like $8 per oscillator of your 100 oscillator DIY project. Suddenly you're getting close to $1,000 just to put together a crazy hack. Why? It needs to be possible to do this kind of stuff for way cheaper, and that's what I'm doing as far as progressing. The name of the chat today, and that's why I dove into this so hard, is hardware democratization. It's all very well getting a $1,000 computer and claiming like, oh, everything needs to be done in DAWs now. Everything has to be plugins now because we can have that. I can afford it. I can use the DAW and I can run the plugins and I don't have to have anything real. It can all just be imaginary. But then you've got all your digital aliasing and the quantization and stuff, and you're dinking around with the keyboard and stuff. This is not what the guy from Seat Lombard was doing when he's patching together chips like this, and the chips are not the expensive part. But here, let me take a moment. This is part of the democratization discussion. I'm looking up the Seat Lombard Deerhorn organ. You can do likewise if you would like. You can see that bits of it are circuit board and bits of it are wooden. It does have knobs. The knobs are not the expensive knobs. It's based on banana jacks. Banana jacks are cool, but I can do that cheaper. And ordering the Deerhorn organ, the connection here is very cool, because if you go to their webpage, go to seatlombard.net, Deerhorn index HTML, and it's a pretty janky webpage, honestly, but it does have drawings of like crazy circuit board designs. And it's like, why would you have to make a circuit board? Just make a crazy nest of wires, just point-to-point wire stuff together. But the circuit board design in this Deerhorn, that's made out of pieces of wood that look pretty damn near hand-carved, and little wood screws and things. And to ordering the Deerhorn, $960.30 for a Deerhorn. $520 for a Tetrax organ. $1,820 for a Quatrax organ. These are things like this. It's just that the guy is good at it. He knows what he's doing. So when he puts together a organ, it's got this kind of stuff. It's got just enough fanciness on it, but it's also handmade. It's like a little sculpture, kind of like this is a little sculpture. It's just a different kind of little sculpture. So when you're buying something from this guy, basically the point of that is this is a crazy circuit bent, raw electronic kind of device. Heinbach can verify, and I too have heard the output of some of these things. These things sound huge. They're amazing. And I know why. It's because they're built out of these raw parts. And It's not just it's not coming out of a computer. It is coming out of a bunch of freaking out circuitry. And you can do that. You wire it together properly and come up with how that kind of stuff is done, and then think of something original and start building them. And maybe carve cases out of wood. Maybe think of something else interesting to do. Build a case out of concrete. Like get a sack of concrete and figure out a way of making molds so that you can do that. And then you have like a turtle with controls on it. And that's your synthesizer. Whatever. Imagine something interesting. And then if you make it and it's good enough and it's playable and you get the right YouTuber to enjoy it, like Heimbach is a real find for this guy, I think. But I don't think Heimbach introduced him. I think he was already a pretty big deal before Heimbach got a hold of him. And a Quatrax organ, which unfortunately I don't think I can patch this through. Maybe it is, maybe it's not. Let's take a moment and see. Nope. I'll patch the link. Might as well. If it's able to show that link. I don't know if anybody can go to that link. You'll probably lose my stream, but the stream is winding up anyway. But Quatrax test. Have a look at that. Have a look at that as far as the kind of people who watch my stuff are the kind of people who would probably be into this sort of thing. You can buy one of those for the price of a small used car. And that's not unreasonable, because there's the guy that's building these by hand. And he's designed them and come up with the stuff to wire together where it's almost like you're building a guitar or a violin by hand. If you can design the thing and it plays nicely and it sounds amazing, and I wasn't able to hear the sound of that one because I'm busy streaming, but I'm willing to bet you that it sounds amazing for this type of instrument, because I see how he's building this stuff. A lot of this stuff is circuit boards, but even then, the circuit boards that guy is making, I've seen some of them. They're not like this. This is a computer-style circuit board. The traces are incredibly tiny. It's all based around the CPUs. It's all based around, as long as you can get a voltage from one place to another, that's fine. That does not take into account the stuff that boutique guitar pedal manufacturers and such have learned as far as kind of wiring that you're using, kind of parts that you're using, sort of the old school stuff that's really cumbersome, and the ability of that old school construction to transmit bursts of energy, say like the switching between square wave outputs, like positive and minus, or 0 and positive, I think is what it would be. The ability to go from the one to the other instantaneously, rather than chugging a whole bunch of voltage through these incredibly tiny hair-like IC sockets with the assumption of as long as the signal gets to the final destination, that's all that's important, right? And you can combine those things. And you can combine those things for incredibly cheaply. And that would mean solder core is my name for what we're doing with this that I'm building up to. And since we live in the modern day, you can use solder core and have your circuitry and ICs making the voice of the circuit be controlled by digital elements that you can program by plugging a USB cable into it. And program something interesting, and then this governs and runs your analog stuff, which is designed on a very different basis, but it needs a brain to tell it what to do, and the brain can be these things. You don't have to build the brain out of the raw bits. You can if you want, but you can also get like a teensy and generate whatever. Or you get a teensy and that becomes your oscillator and it generates notes that are in tune according to whatever format you want, and then you run it into your circuitry. So yeah, Fiat Lombard is a very interesting concept for people to be getting into, in that it is one example, far from the only example. Like, if you get into circuit bending type stuff, for many, many years, you've had things like the Devilfish mods for Roland TB303. And of course, the 303 is your acid synth. And it started out as a very cheap, failed bassline imitator, but it ended up being very relevant. And then you have certain people who will actually increase the value of these things by putting a bunch of weird, crazy circuit bending on them, producing a huge, big, amazing sound. Again, the parts that is done with are not insanely expensive. It's about people being willing to try stuff, and it is about choosing the right bits to get your music thing together. And on that note, I think I'm going to wind up. It's 12:49, so I've run a little bit longer than I was planning to, but that's fine. And I think people have been just listening. Oh, I should touch on some of this stuff, though. Chat has been going by so fast that I was just talking about chips. I'll tell you your birthday, my birthday sometime, Eddie. Mbit plus dither type used in ozone is a high energy noise shaper, and it's good at making not that much apparent noise. However, there are also things about it where if you run it through further digital processing, that can cause a problem. High energy noise shapers don't interact well with, for instance, if you are doing going through like your computer is running at 48K, but the output of the thing you're listening to is 44.1K, all of a sudden the output of the Mbit Plus is going to be really broken because it wasn't supposed to do that. And if you do a higher quality sample rate conversion, it'll behave a little better, but it's still real challenging. Mbit Plus is more fragile than, say, TPDF. A lot of people like doing TPDF simply because it is resilient to anything that you do to it downstream. So it is a challenge doing stuff in such a way that it'll handle downstream digital processing. My stuff handles that pretty well, although dark is probably better than not just another dither at it. But stuff that's unusually high performance in a certain way, like the Mbit Plus, like the Power R3, for instance, those can be more fragile when you do further processing on them. You're building streams? Yes. Setting up compressors and EQs and the likes. EQs, very likely. Easiest thing to do is to start hacking together EQs and make them interesting. And inductor EQs are really very easy. So that's a definite win. Absolutely there would be inductor EQs, because inductors and capacitors and stuff is the guts of what an EQ even is. And it can also be some of the best sounding EQs you will ever find. 3-pole filters, 18 dB per octave. Yeah, this is actually closer to a 2-pole filter, because 1 pole would be just one of these things, and then the more that you add, the more poles you get, and the more loss you get as far as losing energy going into it. And all components do indeed have a sound. So one of the things about the inductors is you can get more mileage out of that without having to run through additional active stages, because every time you run through an active stage like an op amp or a chip, you're going to be degrading the sound and gaining more noise. So active circuits aren't always everything that you'd want. Boop. So I am going to put the live chat away. And I'm going to head out and pursue the rest of my day. But this is a little glimpse into some of the stuff I'm going to do going forwards, seeing as I didn't get a lot of chat in the end there, but that's fine. I guess because I was so into explaining this stuff, people were just listening, and that's cool too. So on the back of that, what I will say is I will catch up with you guys later. I should be doing my music jamming again on Tuesday and Thursday, and we shall see it. I don't think I'm going to be able to do that every week, but I'll do it when I can. And I'll continue getting this stuff together, and the plugins are going to start getting more interesting real quick. Next week is not another dither, or not just another dither. Next week is something else, and the week after that should be more exciting for everybody. But we'll get into that later. I'll talk to you guys later. Bye-bye.